Okay, here we go. We've been talking about volume. If you've not been here, then maybe obviously you've missed these conversations. So, or maybe you were here for part of them, but not all of them. So we talked about volume, and we talked about containers. Like, so if you don't have that in your notes, make sure that's in your notes. And I don't know what's going on here. I don't know if I can. Oh no, 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 no. Oh my gosh. Oh geez, forget it. So, how much space something takes up, or how much space is inside the empty space inside a container. So like this is a container that's made of plastic, and the plastic takes up space, but then inside the cavity, there's an empty space. And so we talked about being able to calculate that one of two ways. If it's a box, then again, the length times width times height measurements calculated, that tells you the volume of the space inside a rectangular box. If you have a cylindrical container, then you would have to go this route, where the volume of the cylinder would be pi r squared times the height. You got to remember that r is the radius, not the diameter. So you'd have to measure across, but then take half of that, square it, multiply it by pi, then times the height of the cylinder, and then you get the volume of the space inside the cylinder. Now again, both of those are calculated volumes using lengths, and that's going to give you centimeters cubed or cubic centimeters for your unit of measure. Then we said, hey, there's also another way to do this. You could fill the container up with water out of a graduated cylinder, keeping track of how much water you put in. And so many milliliters then would be in the container. And so that's what we did in class. We took a bunch of different containers, like we had the blue box, and then we had the tall cylinder, and then we had the little Tic Tac. And so we had several different containers that we used to be able to figure out what the volumes all were. And every group measured 2 containers, and we compiled all of the data on Classroom. So you'll have to check out your Classroom, and then you'll see on your Classroom something like this, where, and of course this is for first period because that's the only class that I've had yet today, or so far today. So you would see a spreadsheet here that looks like this, and this is all of first period's data. Don't write this down unless you're in first period. Then I suppose you would look at this and then write this down. Now notice what we have here. We have water fill 1. So the first group to have each of these containers put their water fill volume in here. Then they put the second group that had that container put their water fill number in here. And then I had the sheet calculate what the average was for those two. And then the average numbers got put in here. That's the one we're concerned with. I want to know what the water fill average volume is between the two groups, just in case one group messed up or something. I figured if we take the measurement twice and then average those two, we'd probably get better results. So we have averages here for the water fill method, but then we also have 2 sets of calculated numbers for the containers as well. So the length, height, and width for the rectangular ones, or for the cylindrical ones, we've got radius, square times pi times the height. And so we have those 2 calculated values, and those are averaged out here. So I have a calculated volume average in centimeters cubed, and then I have a water fill volume average in mLs. So this column, and maybe I should make those a certain color. So, oh no, this is a video. Oh gosh. I can't go in and, oh, geez. So I'm going to have to highlight these two columns here and make those a color so you can easily see which columns are the data that you want. So once we got all that data, which you'll have access to because it's a shared sheet on Classroom, so you will have the data whether you were here and collected it or not. Then you will have to go back to Classroom, and there is a shared link here. This link you will click on, and that will allow you to go to the Chrome Web Store and download an app called Graphical Analysis. It's Vernier Graphical Analysis, and we're going to use that to make our graphs. Instead of doing them paper pencil by hand with the data that we collect in class, we'll be able to use the app here, and it will make things go so much faster. because by now, you should have the skills to be able to make a graph. And on tests and quizzes, you'll have to make graphs. But for homework and for classwork and for lab stuff, you'll use the app because it will speed things up and we can do the science faster if we're not having to wait around for people to make paper pencil graphs and plotting points, and it gets tedious. So you'll get the app, hopefully, you'll open it, and when you open it, you will click on maybe I should, oh shoot, I can't do that right now. There will be a little screen that comes up, and you will click on the manual entry. It should say manual entry on the initial startup screen. You will click manual entry, right? And then it will send you to a page that looks like this. It will look something like this, only it will have an empty data table here. There won't be any points on it. It will just be an empty graph, but this is the format you would see. And here's what you should do. Like what I did here, you'll click on these three dots and it says column options. When you hover over it, you will click on that and you will click on column options. And that is what allows you to change the name of it. So on the x-axis, which is what this first column is in the data table, you will change the name. I changed it to volume in ml or milliliters. That's what's on the x-axis for this graph. I'm making the call as the teacher. I want everybody to have the same looking graph. So you will change that to volume in milliliters, which would be on the x-axis. You will change this to mLs for milliliters. You don't have to change anything here. And you will click apply. I will click cancel. Then you will go to the other column, the Y column, and you will click on that, and you will, three dots, and then you will click on column options, and you will do the same. Only for me, I don't have superscripts. I think maybe your Chromebook might automatically change it. I had to use the Shift 6 to get the caret for power. That's what that means. The caret is power. So it's volume measured in centimeters cubed. That's what I just wrote out there. That's the name of my variable. And again, what's the unit of measure? Centimeters cubed. Don't change anything here. Click apply. I'll click cancel. So you will then put your data in to the data table. Now, everybody's going to have the same. In your class period, everybody's going to have the same data. We're sharing all of the data. Okay? So if we look back at the actual data, what am I doing? Right here. Again, the average values. You're not doing the water-fill 1 or the water-fill 2 or the calculated 1 or the calculated 2. It's the average columns that you'll be putting in those in that data table. All right. Once you get those entered in on your app, then you will see it came up with plotted the points for you. How handy is that? That's amazing. And notice when you typed the names in here, they automatically appeared on your x-axis and your y-axis. Wonderful. Now, the thing that probably didn't happen, like what you see here, you probably don't have an actual x and y axis. Like there's no origin down here. And that's a problem. We need to have the origin in the corner of the graph. So you will then go down to graph tools. So again, hopefully I'm going through this quickly because you can pause the video and then go do what needs done and then get back to the video and see what to do with it. So you will go to graph tools down here in the bottom corner. Click on graph tools. You will click on edit graph options. And you'll see this little screen. Now notice my scaling right now says automatic. I don't want that because it told me where it was going to stop the graph on the x-axis, and it told me where it was going to stop the graph on the y-axis. I don't want that. I want it to go, I click on automatic, and I say always show 0, which means the origin. I want to see the origin on the graph, and that's what you have to change this to, not just for the x-axis, but also for the y-axis. You go down to automatic, click that, always show 0, boom. Now, once I get out of this, once I close this, now I have an origin down here. The origin is there. So I can see the full graph. Notice that big old container here. That was the largest of all the containers. I mean, the biggest one up to that point was about 100 mLs or cm cubes. Now we're up to over 250. That's significant. Now, if I go over here to graph tools again, Apply curve fit. I wonder what that's going to be. That's going to be your best fit. Now, when you click on that, the computer says, hey, do you want it to be linear or a quadratic or a proportional or a power or an inverse? We'll go linear because I think that data looks linear. That's what the program's telling us. And so I click apply. Oh, look at that. We have now a graph with a best fit line that actually fits the data pretty well. I think that definitely looks like a straight line set of data, not curved. Now, are a couple points a little far off? Yeah, but look at the rest of them. We've got 8 of the 10. 1, 2, 3, 4, 5, 6, 7, and 8 that are like hovering right there at the line. These two are a little bit off. I mean, are they really off far? Not very. I mean, it still follows that same trend. So, I mean, I think it looks pretty good. Now, let's see. Some things about this. Notice there's a little box here that gives you some information. Do you know what that M stands for? M is for slope, which makes obvious sense. I mean, because there's an M in the word slope. So, of course, mathematicians think that M would be a good symbol for slope. That's obviously sarcasm. There's no M in the word slope. I don't know why they chose M. Maybe the Latin word for steepness or something. It starts with an M. I don't know. But M is the symbol for slope. And they gave it to us. We didn't even have to calculate it. They gave us the number. Now, what they didn't give us, if you'll notice, they didn't give us a unit of measure. We have to do that. All right. So if you're at home and you weren't here for this, you're going to need to sketch in your comp book from this graph. You're going to need to sketch the information. You don't have to plot the graph. You don't have to make a detailed graph. You're going to sketch in your comp book so that you don't have to pull this file up every time we use it. Some information. So now I got to get back to this. Okay. Now, let's see. Let me make a new screen. Let's see here. Hopefully this will work. Oh boy, I got to get out of this. Oh, come on now. Please work for me. All right, I am going to make a graph, sketch a graph, like what I just had in graphical analysis. And I'm going to say I have volume down here, volume in mLs. That's supposed to be in, oh my gosh, I don't have an eraser. That's supposed to, oh my gosh, in, there we go, in mLs. Measured, again, unit of measure, ml. Here I have volume on the y-axis as well in cm cubes. And again, what's the unit? Cm cubes. Seems redundant, but just do it. I'm going to draw a line on it that's kind of like my line on the graph. So there, I've constructed just a general sketch. Again, don't plot points. Don't scale the graph with a certain interval. Like, don't make the graph. You already did that. But I want you to have a sketch of it in your comp book so that we can look back at it and remind ourselves, oh yeah, that's what that was. We had that here. So that should be in your comp book right now. Now, the slope. I'm going to write slope down here because we didn't have to calculate it. Graphical analysis did for us. So it was 0.99. Now, I don't know what it was for your class yet, but this is what first periods was, so I'm just going to use that number. You write down what it was for your class period based on the data that we had for your class period. I had 0.99. Now, they didn't give us a unit of measure. We got to figure that out ourselves. So what's the unit of measure here? Remember, it's always going to be the rise over the run. Remember, you always, when you find slope, you're taking the rise value divided by the run. So it's centimeters cubed divided by mLs, or slash, we would say, So we would say that this is centimeters cubed slash ml, the rise over the run. Whoa, what the? All right, now I gotta erase this. Oh my gosh. This thing. Yep. No. There was a knock at the door. Okay, let's see. So there we have the slope. The slope right there, right? 0.99 centimeters cubed / mLs. Now, the next question is, how do you write that out in a sentence? Hopefully you can do that. Hopefully you can, in your comp book right now, you can pause the video and actually write out the sentence how we've been writing them all the time. I'm going to go ahead and write it now. Hopefully you paused it to try it yourself first. This is telling us, and this is how you always start the sentence, at least this is how I do. There are, oh my gosh, it's eraser. There are 0.99 cm cubes of volume / or for every what? 1 ml of volume. That's what the sentence says. Like that, that's what the slope says to us. There are 0.99 centimeters cubed of volume for every 1 milliliter of volume. Now, 0.99 is pretty close to what? Hopefully you're thinking 1, which means in reality, what is this telling us about a centimeter cubed versus an ml? They're the same thing. They're equal. This is telling us, this slope is telling us that there's a 1-to-1 here. We have a 1-to-1 ratio, which means they're equal. 1 centimeter cubed is equal to 1 ml. 1 centimeter cubed is equal to 1 ml. Now, that means, think about this. Oh my gosh. In class, I think I had told you or showed you, and you weren't here. If you weren't here, you didn't see this. This right here, this little tiny orange thing, that is 1 cubic centimeter. It is a centimeter by a centimeter by a centimeter. So that is the size of 1 centimeter cubed. Oh boy, oh, I hope I didn't cut off the bottom corner there. Hopefully you can see that. 1 centimeter cubed. That means if I take a graduated cylinder, hold on. If I take a graduated cylinder like this with water in it, and I had a box that was this size on the inside, and I take this and I pour some of that water into that little empty box until it's full, how much water would have come out of the graduated cylinder? 1 ml. I would pour out 1 ml and it would fit perfectly in this box right here. This is no accident. When they developed the metric system, this is what they did intentionally. They said, hey, we're gonna make the meter measure and the liter for volume, we're gonna connect them. We're gonna connect them like this. This box right here, do you know how big this is? It's 10 centimeters by 10 centimeters by 10 centimeters. 10 by 10 by 10. Sketch that out. So that is 10. So it is a three-dimensional box here. We got a box, something like that. And it is 10 centimeters by 10 centimeters by 10 centimeters. Oh, what am I doing? If it's 10 by 10 by 10, again, that's a tenth of a meter. So 10 centimeters, 10 times 10 times 10. How many is that? What's 10 times 10 times 10? I hope you know it's 1,000. So that is 1,000 centimeters cubed. That's 1,000 centimeters cubed. And we just said each one of those is equal to what? Each 1 centimeter cubed is equal to what? Well, it says it on the board behind me. Each one of them is equal to a milliliter, which means 1,000 centimeters cubed is 1,000 mLs. That's 1,000 mLs. Now, what do you know 1,000 mLs is equal to? How many mLs are in a liter 1,000 of them. 1,000 mLs is a liter. That is 1 liter. That's 1 liter. This right here, this box. But except for I have one ml missing, or 1 cm cube missing. That right there, the orange part, the inside of this thing, that is 1 liter. They did this intentionally. They said, hey, if we take 1/10 of a meter, 10 centimeters by 10 centimeters by 10 centimeters, and say this box, that's 1 meter in volume. The significant thing about this is that we don't have anything in the English system like that. If you take an inch by an inch block, does that have like a specific amount of volume? Like, is that what a fluid ounce is? Or is that what a tablespoon is? Or is that what a cup is? No. There is no significance between our cups and pints and quarts and gallons and fluid ounces. There's no connection between those values or those units of measure and an inch on a ruler. There's no connection. But when they came up with a metric system in the 1790s, they decided, hey, we want a unit for volume, but we want it to be connected to the meter stick so that measurements and dimensions match up with what we're calling our volume measure, or a liter in this case. That means, see, I got another one of these blocks like this. I got another one of these blocks, and that's, so if I stack these up like this one on this one, if that's a liter and that's a liter, then this is what? 2 liters. So if you got a 2-liter bottle of pop and you have a box that's this big all over in size, and you pour that 2 liters of pop in there, it would perfectly fill it up. Now notice, this is a little shorter than what a 2-liter bottle would be, but it's also, square, not round. So, I mean, this is the same volume. This is the volume of pop you get in a 2-liter bottle, because this is 2 liters. That's significant, right? So the point is this: from now on, when we talk about volumes, if I tell you a certain volume in milliliters, you need to know that's the same number in centimeters cubed. Or if I give you a value for volume in centimeters cubed, that's exactly the same number in milliliters. They're one and the same. They're exactly the same amount. And again, they did it intentionally. So that's what we got done today. So if you weren't here, hopefully this helps maybe explain what we had talked about. If you were here and you forget what we had talked about, hopefully you can go back and look at this and know what the heck's going on. So hopefully you take care of yourself, be safe out there, and we'll see you later.